Okay, find the length of AB in third form. Now with these questions, right, involving trigonometry, you're going to need to do it without a calculator, all right? In recent exam papers, it literally said, do not use a calculator here. So it's okay to check the answer on your calculator, but you need to show all your workings, right? Which means you can do it without one, and we can maybe check later. Now, in this question, it's got the angle of 45 and 60 degrees. And what's good about those angles is that you can actually work out what cos 45 is, or sin 45 is, or tan 45 is, by drawing a simple triangle. Now, I've drawn one here with the 45 degree one, okay, and it's different to this, right? I'm gonna sort of ignore this for a minute, but I'm gonna note, obviously, we've got a 45 degree angle there. And with a 45 degree angle, it would actually create, if you think about it, it would create an isosceles triangle, wouldn't it? Isosceles, because that's 45, well, that means that would be 45 as well, wouldn't it? Yeah, because they'd have to add up to 90, with the 90 here. And if it's isosceles, then these two sides will be the same. So I will just call them 1, right? Of length 1, right? I always choose 1 because that's the way we would go about this. Now, if that's 1, we can work out that side, can't we? Using Pythagoras. So if you think about Pythagoras, you square that side, so that'll be 1 squared. You square that side, so that'll also be 1 squared, and you add them. And then that would equal my c squared, which is the longer side. And if you work that out, that's 2. Okay, so 2 is c squared, which means then, take the square over, c will be root 2, square root of 2. So that side is square root of 2. And what's good then about this is, right, if that's my angle of 45, then my hypotenuse is here, opposite the right angle. My opposite is there, opposite the angle. And then my adjacent is here, next to the right angle and angle. Now if I wanted sine 45, now remember with our mnemonic, SOHCAHTOA, okay, well, sine 45 will be opposite of our hypotenuse, so it'll be opposite, which is 1, over hypotenuse, which is root 2. And if I did cos 45, okay, that would be, of course, the a over h, okay, so adjacent over hypotenuse, adjacent is 1, hypotenuse is root 2, so it's also 1 over root 2, okay, it's the same. And then tan 45, that would equal to, tan, of course, is opposite over adjacent, so O over A, so O over A is 1 over 1, which is just 1, yeah, okay. So that's my 45 angles here, right, in terms of my sine, cos, and tan. We can use them. Of course, the other one then is 60 degree. When you do a 60 degree, it's not going to be isosceles triangle. The only thing we can think of as 60 degree is an equilateral triangle. So if you think about a 60 degree, that comes up a lot, doesn't it, with equilateral, because with an equilateral, all of the sides are equal, but all the angles are equal. And what I'm going to do, right, I've done a rough sketch here, it doesn't really look perfectly equilateral, it doesn't matter. I'm going to put my 60 degrees here, right? Now I could put 60 there as well, and 60 there, but I'm not going to. And the other thing then, I'm going to label these sides, give them a length. Now I'm not going to give them a length of 1, I'm going to give them a length of 2. So I'm going to put 2 there, and 2 there. We always do it this way. On the bottom is 2 as well, but I'm not going to just write that for a minute. So what I'm going to do, I'm going to cut this, okay? And because this is an equilateral triangle, this will be like a line of symmetry. So actually, we'll split this up. That will be 1, and that will also be 1, won't it? Okay? And this will be a right angle triangle. If I label the sides here, this will be opposite, this will be adjacent, and this will be hypotenuse. Okay? Now, with regards then, sine, cos, and tan, okay, we need to work out what that side is, and you know, you use Pythagoras again, right? But this time with Pythagoras, you know the hypotenuse, and you know the one of the smaller sides, but you need the other small sides. So in this case, you'd be taking away with Pythagoras when you do 2 squared, take away 1 squared. The c squared is that one, isn't it? So 2 squared, take away the 1 squared. That would equal to 3, and then of course, to get our c squared, get this side here, which would be like my a squared, if you like. A squared would equal 3, which means then my a would equal root 3. Okay, so this side is equal to root 3. Okay, and then I can get my cos 60, my sine 60, my tan 60. So sine 60 would equal opposite over hypotenuse. Okay, so root 3 over the 2. My cos 60 would be my adjacent over hypotenuse. That'll be 1 over 2. And then my tan 60 will equal to opposite over adjacent, yeah, over a, so root 3 over 1, which is just root 3. So we can use these calculations to help us work out AB in the next video.